Well, thank you, everyone. Thanks for the opportunity to talk about a little project that's very dear to a few of us. And it's actually not a little project, it's a fairly huge project. But thanks for the opportunity. Again, project in Brownsville. How many folks here from Brownsville? Okay. Okay, a few. Very good, very good. So this is I'm going to provide a little bit of background, a little bit of history. This is some work that's been underway for quite a few years. Let's see if I got the right. So Resacas and Brownsville are distributaries of the Rio Grande River. Right? They were obviously when the river would flood many moons ago, it created these meandering channels that we call Resacas. They're no longer. So Resacas now, there's over 50 miles of Resacas there in Brownsville now. Just within the city of Brownsville, we feed water into the Resacas on a daily basis. So the map that you see there are the three Resaca systems in Brownsville. We have three large systems: Resaca, the Rancho Viejo up in green up there, Resaca de la Guerra in orange, and then down here lighter blue, the town Resaca system. There's a lot of segments. You'll hear people call them by different names down there, but these are essentially the three large Resaca systems within the city of Brownsville. Red outline there is the city limits. I'm going to talk specifically about two projects there in Brownsville that are ongoing right now regarding Resacas, and that's the Restore program, Restore project up in the upper left over here, and then a project with the U.S. Army Corps of Engineers that what we call Contract 1. Resacas are, again, we feed them on a daily basis. A lot of the storm drains, feed into these waterways. We use Resacas for water storage. One of the Resacas specifically, we're able to pull water from that Resaca onto used for water supply. By the way, I'm with Brownsville Public Utilities Board, the utility there for the city of Brownsville. So we do pull water from one of those Resacas for storage for our water plants. The Resacas also they service drainage for the city of Brownsville. Here comes a hurricane or storms. We have the ability to lower those Resacas. And not just us, the city of Brownsville, some irrigation districts. These Resacas are used for multi-purposes. Clearly, there's the environmental benefit of it, right? Resacas are a great water source for wildlife. And really the focus of our project is ecosystem restoration project. But clearly with multiple benefits. Economical benefits, again, they're within the Central Pacific Flyway, so they serve as that water source for migratory birds. Existing challenges. Resacas, as I mentioned earlier, have been silting in. So some of these Resacas that have anywhere from 2 to 7 feet of sediment that slowly are degrading water quality, habitat, et cetera. Aging infrastructure within these Resacas, there's also some infrastructure, weirs, valves, and so forth that over time have been degraded. As a result of all the urban ag development throughout Resacas, we're essentially losing this habitat. We're down to the last 1% of Resaca habitat. Certain specific vegetation communities that are literally imperiled with extinction now. So we're down to the last 1% of Resaca habitat. A lot of these habitats, Resacas are fragmented. You build, naturally there were long meandering channels. It's a city now. So there's roads that cut across with them, flow in many cases. You no longer have the natural flow that you used to once. So some of the challenges that and then pollution, clearly a lot of homes in some cases, a lot of nutrient runoff, you have algae blooms and so forth. So definitely a need to restore the Resacas. These are some of the restoration measures for the program. And in some areas we'll use some, other Resaca settlements will focus more on others, but these are all the different measures that we're employing to restore these Resacas. Dredging, see a photo up at the upper right there. Dredging, excavation, and there's some areas such as La Posada Montezuma Cypress area where you don't have water. So we're going to go in there and excavate. We're able to add water occasionally there, but there are other Resacas where you already have the steady water flow there. So dredging in some cases, excavation in others, reshaping of banks. There are some areas where you can reshape a bank, such as Montezuma Cypress Preserve, where you're able to go in there and reshape a bank so that you have more of a natural slope. There are going to be other neighborhoods where it's already developed. Clearly not going to be able to reshape banks there because you already have retaining walls in homes. So these are the different measures that we'll employ throughout the program. Invasive vegetation, there's a lot of Brazilian pepper tree along the Resacas down there. So in some areas, we'll be removing that invasive vegetation and coming in with native vegetation. So background, back in 1998, this is a little more tied into the work that we've been doing with the U.S. Army Corps of Engineers. Back in 1999, that is, the House Committee on Transportation and Infrastructure drafted a resolution that specifically talked about the authority for the U.S. Army Corps of Engineers to be able to study the Resacas. So you can clearly see that this is community leaders dating many years ago recognized the importance of these waterways. From an economic development standpoint, from a wildlife standpoint, they clearly realized that, hey, look, we need to do something about these Resacas. And this is during Solomon Ortiz's up at Congress. And ever since 1999, shortly after that, we began the utility in partnership with the city of Brownsville. We began work with the U.S. Army Corps of Engineers. What you do early on, you begin with reconnaissance phase and then feasibility and so forth. So clearly this work has been ongoing for quite some time. Did I get the right button? Yeah. So then in 2009, the city drafted this Imagine Brownsville Comprehensive Plan. It essentially looked at the city as a whole and looked at utilities and so forth. But one element of the plan focused on Resacas and improving Resacas. So we've used this Imagine Brownsville Comprehensive Plan back in 2009 as our guide, at least for early on, for the Resacas that we worked on at the beginning. We used this Imagine Brownsville Comprehensive Plan just to guide us early on. In 2011, the utility took on the project, took the lead at Brownsville Public Utilities Board to begin the effort. You know, okay, who's going to do this? Off we go. In 2011, the utility created a department, brought in equipment to begin this effort. Capital cost right up front, $6.7 million just that first year to bring in some dredge equipment, some dewatering equipment, auxiliary equipment, dump trucks, front loaders, and so forth. So in 2013, we actually began dredging. That is, off we go. With that first element, first thing we know we needed to do was remove the silt, the sediment that has been accumulated. Along with that were other components, the plantings, the native vegetation, and so forth. But we knew we wanted to begin with the dredging portion of the project. And then from 2015, that in a nutshell is we've continued to work with the U.S. Army Corps of Engineers, 2015. And then in 2016, we actually applied for some restore funding. Restore was some funding, Restore Act, as a result of the oil spill, the BP, Deepwater Horizon oil spill. There was some funding available to Texas, to Gulf Coast states. And we applied for some funding back in 2016. And then eventually we were awarded some funding, $4.6 million for this effort in 2020. And since then, we've continued working with the Corps. Again, two different projects, Restore, where we're dredging in one particular area, and then with the Corps, where we're working with the U.S. Army Corps of Engineers and designing some improvements. So a little bit of the dredgers. This is the dredge equipment that we use. Photo in the upper left is our larger dredge. We have a couple of those that we use for the larger Resacas. The one in the upper right is called a mini dredge. That we've used in different places, such as the zoo, Gladys Porter Zoo, a little more confined channels, bridges. You can't use larger dredge. One in the bottom left is a submersible that we tried. Not very successful with that one. We actually returned that one. But that was a submersible, underwater. Didn't travel too far, let's put it that way. So we resorted to divers. I mentioned divers earlier on. We resorted to divers there within the zoo, literally divers underwater, removing sediment. We'll just give it a minute. You can see what it is. It's about a 40-foot dredge in length. We went with this type of dredge, so we knew we had to go one segment to another. It's transportable. You'll see attached with some floating pipe. That's how we pump material onto our dewatering system. Up at the bottom, you'll see an auger or cutter head. Back here, star wheels, that's what help you propel the dredge back and forth.
Attention planning patients. Library will be closing in 55 minutes. If you were dropped off, please make plans to call your next information to right for 7:45 p.m. Thank you.
So here you see it being pumped to just a containment base. Our situation is slightly different. We've actually used a similar containment basin at one of our facilities. I think next to, this is a dewatering system that we employ. Let's go ahead and get to the next one. Within 24 hours. The equipment that we use, you'll see a little bit. There's another video that shows it's slightly different, but this is the dewatering equipment. We collect all our material. We pump material onto this site, and it's all collected in these containers. This helps it dewater. It's a rapid dewatering system, back to your question. And then you'll see it, they remove the sediment and off we go. We do this process on a daily basis. So early in the morning, say 8 to noon, we have staff emptying these boxes, these container boxes. You see the sediment there, that's the sediment that we collected the previous night. This particular equipment is very labor intensive, unfortunately, but this is all in the morning. They come in, clean these boxes, haul off the material, and it's a daily process. The other video you were unable to see is how the material makes it onto this site and the process that it goes through for a little bit of separation. Okay. So we don't have the video, let me just back up a little bit. What you see here, this is our dewatering system. You see the dredge in the upper left, pumps the material through these different units, where you essentially have a shaker or separator that separates trash. We collect a lot of trash. It goes on to another unit where we separate sand, finer material. We collect some sand. And then ultimately you're adding some polymer, a little bit of chemical so that it helps with that rapid dewatering system. It coagulates the sediment, essentially separates your water and your mud. Ultimately, it ends up in these, what you see down here, called TerraCore, which are those boxes that you saw earlier. And then off we go with the removal. All morning, you're cleaning, emptying the material from the night before. After lunch, you're dredging and you fill up the boxes. So our limiting factor is literally those boxes that we have. But we repeat that on a daily basis. So when we began dredging in 2013, this is what we call internally our phase 1 Resacas. If you're familiar with Brownsville, we're talking about the Dean Porter Park area. Cemetery, Resaca, the Gladys Porter Zoo, and Resaca Boulevard. Those were the first set of Resacas that we dredged. And at that point, it was still self-funded. We still hadn't received grants or funding at that point. Challenges, you see these tires, the very first Resaca that we dredged, unfortunately, was the dirtiest. In about a 2,000 feet segment, we removed a little over 200 tires from that waterway. And that's what you see up there. That's what we collected. The first, about 156 cubic yards, just those first few Resacas. In addition to dredging, one of the things that we did there at Cemetery Resaca, the very first Resaca that we did, we were also piloting, the resloping of banks. In some cases, bottom right, the bank was too steep, so we didn't have, you had a road right next to it. So we really didn't have the ability or the space, quite frankly, to have that nice gentle slope so that you do have amphibians, be able to come in and out of those waterways. So in some cases, we have to resort to riprap, but then wherever we could, we did left photo up here to the left. We did a little bit of resloping, removed invasive vegetation, a lot of Brazilian pepper tree, and then came in and planted native vegetation. So this cemetery was, quite frankly, our pilot. The first time we did that, and we learned quite a bit just off of that, what worked and what didn't. One of the things we did there, we also added some aquatic vegetation. Well, clearly, the nearby ducks took care of that vegetation for us. We clearly removed it. So we learned from that, and as we move along, we're adding a little bit sturdier cages and so forth. And not only that, nutria. There's some nutria in this particular area that are, and carrizo as well. So cemetery, so again, dredging was one element, bank improvements is the second, and then the third aspect of the project is you've dredged the Resaca now, you want to protect that investment, right? So you don't want erosion back in there. One of the things that we piloted there as well are the stormwater management around that area. Photo on the bottom left is essentially the same one as the bottom right. And what it is just a stormwater catch basin, essentially. So if you get rain, it'd go down the storm drain along with trash and sediment, and it would go straight into the Resaca, right? Well, what we did here in collaboration with some partners, built this stormwater retention basin where now it rains in this particular area. It still goes down the storm gutter, but you capture your sediment, your rain in this basin before it overflows into the Resaca. This was a little bit fancier project, but then upper right, something as simple as some gabion, rocks where the storm drain runs the streets to the right over here. Instead of it going straight into the Resaca, you capture some of your trash. So these were things that we were piloting right up front, those first few years with that first Resaca. And we've learned a lot. One of the things is clearly the cost. Something like this throughout the city, everywhere, clearly, very expensive. Something like upper right, a lot less expensive. So we're learned a lot, and we're, trying different things as we move along. Now, one of the things that we're using are what's called storm interceptors, literally inside the storm drains to help capture runoff and sediment and trash and so forth before it makes it into the Resaca. All right, so moving on to the core project. I'm not going to spend a lot of time on this, but early on, Resaca Boulevard, small segment, probably about 2,000 feet as well, where we worked with the core feasibility study that was completed between 2015 and 2017. Improvements, did some bank improvements at a cost of about $1 million, roughly $1.035 million, and the core cost shared those improvements. It's 65-35 share. They pitched in 65, and our share was 35%. And so that's the photo on the right is Resaca Boulevard, a 2,000 feet segment. Same thing there. Went in there, removed Brazilian pepper tree, invasive, came back with some of the natural vegetation, resloped. But at this point now, we had the assistance of the Corps. They helped fund the project. Submerged floating vegetation. You see the the cages for the vegetation to keep wildlife away. Some emergent vegetation, riparian vegetation. So that's the first effort with the Corps, Resaca Boulevard. After that, we've continued with the Corps on a larger scale. From 2015, a feasibility study was completed. By 2018, where we looked at all the 3 Resaca systems within Brownsville, those 50 miles. A lot of effort, about 3-year effort, looking and assessing the habit, the Resacas, the water, hydraulically, and so forth. The study was completed in 2018, and we were fortunate enough to get it into the AWIA, the America's Water Infrastructure Act of 2018. So essentially, by getting it into this act, it authorizes the construction or improvements moving forward. It's essentially an authorized project now. What the study found, what the study recommended, again, I mentioned that we're down to the last 1% of Resaca habitat. Well, these are the 3 vegetation communities that are hurled with extinction. And the Corps recognized that in order for the Corps, the U.S. Army Corps of Engineers, to be able to move forward with a project like this, they have to ensure that the project is of national significance. And because of the fact that we're down to the last 1%, they recognize that, and as a result of that, we now have that Chief's report, and it's in the AWIA. From the feasibility study, a national ecosystem restoration plan was developed, and that's what we will be following for the larger project with the U.S. Army Corps of Engineers. And what you're looking at here are Resaca de la Guerra and Resaca del Rancho Viejo. Those are the 2 Resaca systems that will be improved via this plan. And you see some little boxes, some numbers. It's the different segments that they'll be looking at. They're proposing to improve. You'll note that it does not include the town Resaca system. Although it was evaluated, ultimately these 2 were the ones that were more cost effective for the Corps, because they did have those pockets of vegetation where you could go restore and preserve. The town Resaca system, unfortunately, a lot of that is already developed. Very little opportunity for restoration down there. But we are tackling the town Resaca system via the Restore project, a different project. So back to the Corps, the contract 1. This is the very first contract. Some project management plans and some design agreements were signed between the city of Brownsville and the Corps. The design of this very first contract, which is the Montezuma Cypress Preserve, the design alone was about $2 million, $280, and that was also cost shared. So the design is underway. It's now at 95% design. And what that's looking at is our 3 segments down in what we call internally Jagu Resaca, but it's the La Posada Montezuma Cypress Preserve that Robert just mentioned, which is at segment 93. So what we're looking to do there is improve connected 3 Resacas. Segment 72, you'll notice that has water. Segment 93 right now does not have water. Although we have the ability to pump some water in there, we're looking at a more permanent structure to be able to get some water from 72 to 93 on a more permanent basis. So there's going to be some infrastructure, some weirs, a gate valve, and a pump. That's all part of the project. And this Resaca segment 94, right now it's just a drainage ditch. And so we're looking to convert that. Because you'll notice if you look at further down here, that was essentially a continuous Resaca at one point. And so the goal is to be able to reconnect those 3 segments. This is what we call contract 1 out of 16 contracts, or essentially looking at the entire The totality of the project with the Corps is looking at 16 contracts. This is our very first one. And so it'll span a number of years. But originally, we would say, 16 years. But no, we're quickly finding that each contract, just design takes, 2 years, and then construction. So it's 16 contracts over quite a few years. And just some of the infrastructure I mentioned, pump, weirs, for water management. The goal is to, the goal of the project is to have it mimic its natural system. During some seasons, there'll be a little more water than others. So this is Resaca, or La Posada Montezuma cypress. For those of you that don't know Gene, he's essentially that's his playground. That's his baby. So if questions pertaining to this particular area, I'm certainly be glad to answer a lot of those. But nevertheless, this is our first contract. This is what it looks like now. Resaca. You notice on the left, there's beautiful Montezuma cypress trees, and we can discuss that in much further detail. And the history of this bridge here is 1893. A lot of history there. First Resaca that we're wanting to restore. Clearly, you look at it and it's really already pretty neat, right? But there is, you don't see it here, there is some invasive vegetation that we want to address, especially in a certain portion of the area. And then there's also some sloping we'd like to do, add a little more native vegetation, and then some of those water control features. And that's where we're at with this project. We're at 95% engineering design. Some of the things that we need to, that we're working on next, and you'll notice that it's tentative on dates, but working with the irrigation district and the drainage district, have some ownership there, just working out some agreements with them, then working with the city of Brownsville and the Corps and some memorandums of understanding as we move forward. And then ultimately, we have a very rough tentative construction start of the beginning of next year. The construction start is still contingent upon some congressional appropriations, some funding there, but at least that's our goal. Hopefully be able to start in January 2024. Now how I'm doing on time. I'll go through this one quickly. The other project that's ongoing, this is where we're actually dredging, and that's Restore. The Restore Act of 2012, Deepwater Horizon oil spill in 2010. As a result of that, there was funding for Gulf Coast states. And so we applied, and ultimately in about 20, we received $4.6 million for that effort. That project alone, we're barely in what we call phase one. That project, this is now the town Resaca system. Keep in mind that the Corps is not looking at this system any longer. But so Restore is looking at that smaller Resaca system down there in Brownsville. That's the watershed, the town Resaca system, and some of the proposed improvements, stormwater interceptors, I talked about that, to be able to contain some of the sediment before it goes into the Resaca so that we don't resil, so that the Resacas don't silt back up. Some bank improvements, you'll see along that peninsula, there's green strip. So there's already design underway to remove invasive and come in with native. And dredging as well, and then some infrastructure, weirs, valves, to help with the water management along that Resaca. All those little red dots are those storm interceptors that will help capture all that sediment within that area before it makes it into the Resaca. So that's really it about the projects as a whole, and I'll be glad to answer any questions. Clearly, part of our effort with this program, obviously, it's been ongoing for a while. It's been ongoing for a while, but we definitely want to do events like this. We really appreciate you all giving us the opportunity to talk about it. to talk about it. And we welcome any other opportunities so that we can talk about the project. More than anything, just educate our community on the benefits of the project. One of the things we're going to do a little more of is some work with the school districts. Earlier on, we had a little bit of what we call the Junior Resaca Explorers, where we would had a little program where you teach the school kids about the project early on. So we're going to revamp that here soon. Children's Museum, for anybody that has children, little ones at the Children's Museum down in Brownsville, there's an exhibit, a Resaca restoration exhibit, essentially for the little ones, that teaches them a little bit about, the importance of protecting the Resacas there in Brownsville. Lastly, last slide, we do have a lot of folks that have supported the project, and your group is one of them, and we're very grateful for that. So thank you for that. As a result of that, our congressman is pushing forward some funding that hopefully will help the project, a community project funding support. So thank you for that.